At midnight, the power meters in one city started running backward. Streetlights glowed, transit lines hummed, apartments stayed warm, yet the grid showed a surplus. By dawn, the local utility had sent out text notifications that sounded impossible. Energy credit issued. Your home earned power profits overnight. This isn't utopia talk. It's the real outcome of positive energy districts, the boldest experiment in urban energy history. These districts don't just offset consumption. They produce more power than they use, turning neighborhoods into living power plants and citizens into paid participants in sustainability. In Umeå, Sweden, smart grids and AI-optimized renewables already cover 117% of local demand. The extra 17%, pure surplus, flows back to the national grid, earning residents cash through real-time trading platforms. Houses that once drained energy now generate income. Think about it. A city that doesn't wait for sunlight, it invests in it. A skyline where every surface is a generator, and every citizen a shareholder in clean power. If cities account for nearly 70% of global emissions, what happens when they start printing electricity instead of bills? For 2 centuries, cities have been the engines of civilization, and the lungs that can't stop choking it. They cover barely 3% of Earth's land, yet consume up to 3/4 of global energy and produce 70% of greenhouse gases. Every skyline you see lit at night represents not just progress, but planetary cost. Each week, humanity adds another million people to urban areas. By 2050, 7 in 10 humans will live in cities. That's the equivalent of building a new Paris every 5 days. If we keep feeding those cities with fossil-based power, the math of climate change becomes insoluble. But hidden within that challenge lies a paradoxical opportunity. The same systems driving the problem can become the solution. By wiring entire districts with renewable generation, battery storage, and predictive AI, cities like Amsterdam, Rotterdam, and Umeå have begun to flip the equation. Their buildings don't just save power, they make it. Their sidewalks harvest kinetic energy from footsteps. Their heat networks recycle warmth from data centers into homes. For the first time, technology allows urbanization to heal rather than harm. Yet every innovation reveals new tension. Who controls the energy surplus? Citizens, governments, or corporations? Can older cities retrofit centuries-old infrastructure fast enough? And will energy-rich neighborhoods deepen inequality between those who can afford solar arrays and those who can't? The next minutes will show how a handful of experimental districts around the world turn design blueprints into functioning energy-positive ecosystems, and why the rest of the planet's cities have no choice but to follow. The dream of an energy-positive city didn't start with an algorithm. It began in a desert. In 2006, Masdar City rose from the sands of Abu Dhabi as humanity's first attempt to design a metropolis that could power itself. Solar arrays shaped like wings tracked the sun across the dunes. Narrow streets funneled cooling winds through traditional courtyards. Buildings made of carbon fiber panels whisper the promise of a city that breathes sustainability. Masdar didn't hit every target. It still struggles with population and scale, but it proved that a city could be engineered as a living energy ecosystem. Fast forward to Europe. Policymakers saw the blueprint and simplified it into a replicable code. The EU's Strategic Energy Technology Plan transformed Masdar's one-off experiment into a movement called Positive Energy Districts, PDS. The rule book was radical in its simplicity. Every district must generate more renewable energy than it uses, and it must prove it annually. Cities like Amsterdam, Rotterdam, and Umeå became laboratories. Engineers modeled each street with digital twins, 3D data replicas showing wind flow, solar exposure, and heat loss, then used AI to script efficiencies normally invisible to planners. The prime directive shifted from minimizing harm to creating surplus, turning architecture into infrastructure. Walls became batteries. Windows became generators. Waste heat became currency. Behind the scenes, an emerging cast of scientists, Evelyn Vassiliadou, Johannes Kester, and municipal leaders across Europe, coordinated the networked experiment that gave birth to real energy-positive neighborhoods. Each district proved that sustainability isn't a slogan, it's physics applied at community scale. And now those digital twins are learning. The next generation of smart districts designs itself, letting algorithms adjust geometry, materials, and local energy flow automatically. The line between urban design and artificial intelligence just blurred. The secret behind energy-positive cities isn't one technology. It's thousands of tiny generators hiding in plain sight. Look down. The sidewalk under your feet is alive. Piezoelectric tiles harvest the pressure of every step, converting it into microbursts of electricity that feed nearby streetlights. In high-traffic districts, those walkway networks power Wi-Fi hubs and EV charging kiosks, lighting the way without touching the grid. Look up. The glass towers shimmer, but not just from sunlight. They use it. Transparent solar photovoltaics, TSPVs, turn windows into stealth panels that capture invisible ultraviolet and infrared light while letting daylight through. Offices become vertical power plants, generating enough energy to offset their own lighting and cooling. Now listen. Between buildings, the wind hums through channels shaped by algorithmic architecture. Instead of fighting turbulence, these districts funnel it. Vertical axis wind turbines, silent, compact, omnidirectional, catch Eddie's traditional turbines waste. On rooftops and bridge girders, they spin quietly, adding power where the breeze is strongest. Beneath the streets, thermal loops move like urban arteries, carrying waste heat from data centers and subways into homes via heat exchangers. Copenhagen's Nordhavn district recycles enough of this free warmth to cut heating energy by 30%. Even the wastewater network generates power using microhydro turbines tucked into pressure valves. Each layer, solar, wind, kinetic, thermal, feeds into AI-orchestrated microgrids that balance supply and demand in milliseconds. The result, a city whose total output exceeds consumption, turning excess into currency. What once drained planetary power now exports it. And here's the twist. The most revolutionary component of all isn't physical infrastructure. It's the digital brain learning to coordinate this living network like a single organism. At sunset in Umeå, Sweden, the skyline glows, but the power doesn't come from a grid. It flows to it. Bleeding-edge buildings quietly upload surplus electricity generated by their solar glass and microturbines. Dashboards in every home show something no city dweller ever expected to see, a credit balance beside the word energy. In that moment, sustainability stops being sacrifice and becomes profit. The same walls that once trapped heat now sell light. Every window is an account, every roof an investment. The city itself earns. Zoom out across the planet. Amsterdam's floating neighborhoods trading electricity peer-to-peer. Master's desert towers reflecting sunlight into power. Singapore's vertical forests breathing carbon into currency. The idea has scaled beyond architecture into philosophy. For centuries, cities consumed the earth to survive. Now they can feed it back. This is a pivot from extractive to regenerative urbanism, the first time human settlement mimics ecosystems, capturing energy, recycling waste, closing loops. The fossil fuel metropolis is becoming a living network of producers, each block humming like a solar cell inside the planet's largest machine. And tucked inside those smart facades is the real story. The quiet alliance between design, data, and human intention. Technology doesn't save cities. People designing intelligently do. Because what we build next decides everything. Next on Urban Pulse Innovate, AI architects, how algorithms are designing the smart cities of the 2040s. We'll decode how neural networks now co-author skyscrapers, transport systems, and carbon-negative materials. The future city isn't waiting to be imagined. It's already generating power right outside your window.